Alright, so here we go, the last part of inverse trigonometric derivatives. Okay? So last time what we learned was the derivative rule for arc sine, which is the same as writing it like this. The derivative rule became 1 over 1 minus x squared underneath the square root. So what I'm showing you today is, not always is this nice and pretty like just an x with a positive 1 coefficient. It could be 2x, it could be x squared minus 1, it could be something other than x. And what we do to show that is we put the letter u. Because the u is saying like a composition. It's saying something other than just x. So the rule here, when it's talking about something other than just x, is going to be 1 over the square root of 1 minus u squared times the derivative of the cream. So whatever u is, that's the stuff in parentheses, you would multiply by the derivative of that at the end. Okay? Now let's go to arctangent. Last time, we are coming up with this from derivative rules that we know, as well as trig manipulations that we know. So if I looked at this and I knew that arctangent is going to give me some kind of angle. Here they're just using the letter y, but y represents an angle. I could, like last time in class, draw a reference triangle, and tangent is x over 1, and tangent is opposite over adjacent. So opposite is x, adjacent would be 1. And I use a reference triangle in Pythagorean theorem so that I can say a squared plus b squared, and then take the square root, is going to be c. Okay? And this right here will simplify just to 1 plus x squared. So we found the missing piece from our reference triangle. Okay? From here, I'm going to use derivatives, and I'm going to take the tangent of both sides so that I have this left over. Because remember, arctangent and tangent, they cancel to a form of 1. So now I have tangent of y is equal to x, and here is where I would derive. Anyone, what's the derivative of tangent? Secant squared of the stuff times dy dx. Chain rule is equal to what? What's it equal to on the right side? What's the derivative of x? Just 1. Okay? So secant squared of y dy dx is equal to 1. And now, if I get dy dx all by itself, which is what I've been trying to do, it's 1 over whatever the secant squared of y is. And just a reminder, secant squared is taking the secant of y and then squaring it. They mean the same thing. Okay? Now, let's go to our triangle. And the secant from this angle of y, secant is the flip of cosine. What's cosine? Adjacent over hypotenuse, right? So katoa. So secant is the flip of cosine, so it's not going to be adjacent over hypotenuse, it's going to be hypotenuse over the adjacent, which is just this over 1. Okay? And since we're putting all of this here where secant of y is, and then we're squaring it, my answer for this particular one is dy dx is equal to 1 over 1 plus x squared. So, if it's u, a composition, something other than just a normal old x, the rule for this, remember you learned product rule, you learned quotient rule, all these rules. The derivative for arctangent will be 1 over 1 plus u squared times du dx. Got to multiply by the derivative of that cream. And that du dx is not in the denominator. It's like multiplied with the whole thing. So like whatever that value is over 1. Okay? Questions? Okay, so those are the only two for the sake of time that I will show you basically the long way. Arcsecant, I'm not going to show you just for the sake of time. But these are the 6 that I want you that we need to memorize for the test. Okay? Here we go, and I'm going to help you memorize them right now. The arcsine and the arc cosine are very, very close to each other. They're exactly the same. The only difference is that cosine is negative. And I've helped you out with that before, that all derivatives of cos are always negative. So cotangent, negative. Cosecant, negative. Okay? Notice how equation-wise those are the same. 1 minus. These are the same equation-wise, except for the negative, of course, but it's 1 plus. Okay? Which makes sense because tangent, like we saw that last example, it's going for the hypotenuse per se. And the hypotenuse would be a summation from A and B. And then last but not least, these are the weird ones. The thing that I would say to memorize is that cosecant and secant both have an absolute value of u right there. And instead of 1 minus u squared, which is very, very close to sine and cosine, or arcsine and arc cosine, it's u squared minus 1. Okay? But for the sake of time, I'm not going to show you that proof, if you will. Let's go now to the derivatives. So I'm looking for f prime of x, and here's f of x. And it's using the arcsine. So I'm going to use this rule of differentiation. Remember, the stuff is u. So this is u. So it would be 1 over the square root of 1 minus 2x in parentheses squared times what? Times 2. And simplifying this out, you would have 2 over the square root of 1 minus 4x squared. Because that 2 right here will make this become 2 squared, and then we'll make the x become x squared. Any questions? Alright, so let's look at arctangent. Arctangent is going to look at this memorized rule of differentiation. So it'll be, you help me out, 1 over what?
1 over 1 plus parentheses 3x squared.
Times 3. So it would simplify to what?
1 over 1 plus 9x squared.
Times 3, yep. So it would simplify to 3 over 1 plus 9x squared with no parentheses. Questions? It is a lot of memorization. It's just more rules of differentiation. So f of x. Let's do this one. Arcsecant is this one. Here we go. So this one is going to be 1 over the absolute value of the stuff. Okay? And it's going to be times the square root of the stuff, notice my use of parentheses, squared, minus 1. Then times the derivative of the cream. What's the derivative of the stuff? E to the 2x, that's the carbon copy,
Times by 2.
times 2. If you need me to repeat it, it's the carbon copy times the natural log of the base, which we know is just what? 1. So you don't have to write that down. But times the derivative of the power. And this would simplify to this. This is how I want you to write. So we know that natural log of e is just 1. We don't have to write that. Well, we will write it as 2e to the 2x over e to the 2x, and then all of this other stuff. The square root. Let's see if you know your algebra 2. What does e to the 2x squared become? E to the 4x. Perfect. Because all you do is a power raised to a power, you multiply. Now the question that people ask around now is they ask, does this and this cancel? No. The answer is no. You're correct. Why is it that?
Because it's a coefficient. Is it because it's absolute value?
Well, here's the thing. There's multiplication here. You with me? And if these absolute values were not there, you can cancel to a form of 1 between multiplication. But because those absolute values are there, we cannot cancel that to a form of 1. And the reason of that is that we don't know if it's the plus or minus version of it. Can you tell me what this is? What's the answer to that?
Just x.
Just x. What's the answer to this? X. Because absolute value is both positive and negative, yielding that same answer, because that's what absolute value does, we don't know which one this one is. You with me? So we're going to leave it, and this is what I tell my students. If you ever have a variable, leave it. If you ever plug in numbers, quantitative constants, then you can parenthesize it after you've made it positive. But if it's still variegated with the variable, leave it just like that.
But wouldn't it become positive anyway after you...
I know what you're talking about, but here's the thing.
Because the top could be negative, so
Yeah.
that's why I can't cancel it.
So you're not really canceling it per se. The only thing that I could kind of get close to a little bit, kind of like showing you what's going on, is remember when we did stuff that looked like this?
Oh, right, because if the top were a negative power, then
Yeah.
it'd be like 1 over.
So it depends on the domain. So when it's with a variable, that's what I'm saying, just leave it with the absolute value. Throughout the year, you'll see this a lot. When I'm asking you what is this at x is equal to 10 or x is equal to negative 5, then you solve it, make it positive, make it in parentheses, and go from there.
Is it because the variables and the exponent, or does it not matter?
It's because of the absolute value. It's not because of the variable being in the exponent, it's because of the absolute value.
Okay, so even if it was absolute value, but it's not in the exponent, you can't.
Correct. Cool. Like, here's the thing. Let's say that there was no x, and this wasn't there. Then you could cancel them, because there's no variable. It's just going to be e no matter what. You see what I'm saying? But on the other one, it makes the top either a positive or a negative. You see what I'm saying? Okay. All right, so now let's go on to this last one. So this one is looking at arc cosine, arc sine, but it has a cosine in front. So the question is, which one are we looking at? And we're going to take the derivative. So there's two different ways that you can do this, and depending on how well you memorize stuff, will dictate which path you choose. Okay, so here we go. I'm going to show you, let's say that you forgot the rule of differentiation, but you do remember how to do pre-cal. So this is like the pre-cal way. Okay, here we go. I'm going to look at arc sine of 3x. And all of this right here is theta. All of that. Everything that I highlighted in green will give me an angle, and I'm going to call it theta. Now with this piece that I highlighted in green, I'm going to draw this triangle. 3x over 1. So 3x and 1 goes there. Because sine is opposite over hypotenuse. Solving for the missing side will be c squared minus b squared. Again, in parentheses, this would be that. And then take the square root. So now if I said, what's the cosine of theta, because all of this is theta, what's the cosine from here? The square root of, yeah, it's the adjacent over the hypotenuse. So the adjacent is this right here. Adjacent over the hypotenuse. So all this could be rewritten as the adjacent over 1. And now if I ask you to derive, you can do this. This is just regular chain rule. Because this is 1 minus 9x all to the power of 1/2. And you help me out here. What is the derivative? What's the derivative of this over here? 1/2 times the stuff to the negative 1/2. Let's carbon copy that stuff real quick. Times what? Negative 18x. And if I simplify that out, I would get negative 18x in the numerator, and I would get 2 times the square root of 1 minus 9x squared in the denominator. And the 18 and the 2, even though the 2 is a coefficient of the square root, would reduce to what? Negative 9. So this would be the answer. Now, knowing the rule and knowing chain rule, I don't have to do all that. I can go straight from this equation right here and start taking the derivative. Instead of using pre-cal, go straight to the calculus. Okay? So let's look at the rule of differentiation. First of all, looking at this problem, the derivative is going to be the negative sign of all of that cream, which is arc sine of 3x, times, you with me? Whoops, I got to do arc sine.
Wait a minute.
Oh, hold on. What?
On the first one where you were solving it with the pre-cal, were you doing the triangle?
Mm-hmm.
You said that the sine was 3x over 1.
Mm-hmm.
But it said that it was the arc sine.
So the arc sine is the angle. What I did was the sine of theta is 3x over 1.
Oh,
But it's
right.
the same thing.
Yeah.
So here, I'm going to just go straight to calculus and say, what's the derivative of the outer shell, like Oreo cookie method? The derivative of cosine is negative sine of the stuff inside times the derivative. So now, in case you forgot, this is the derivative for that. That's the derivative rule for arc sine. So I would multiply it with 1 over the square root of 1 minus 3x squared times what? 3. Okay? What happens, guys, to this sine and this arc sine? What happens to those? They cancel to a form of 1. So all I have left in the numerator is a negative 3x times 1 times 3, which is a negative 9x, which is what you see over here. And then all I have in the denominator, simplified, is the same thing. Cool? Two different ways, any way I prefer that you use, of course, the calculus method with the chain rule. But if you get stuck and you want to use the pre-cal, that's okay because you're still deriving down here. But you have to do some reference triangle work. You know what I mean? All right. Questions? Yes?
How did you said something cancels?
Yeah, so arc sine and sine cancel to a form of 1. Just
So
like,
because 3x is left.
yep, just like those are inverse functions of one another, and they'll cancel to a form of 1. Okay, so I think I have one more, and then we will go to the review. And again, we're going to work on however you guys want to look at this. Write the equation of the line tangent to the graph. Here's the position function. Here's my at value. And we want to ultimately come up with something that looks like the equation of the tangent line. So far, I have this, which is my x1. How do I get, let's say, the y value? How do I get that? Plug it in, right? So I'm going to plug in this right here. So here we go. The arc cosine of negative root 2 over 2. This is a little bit review from what we talked about last time. We learned that the arc cosine's range is right here. So now I got to look at these two quadrants and figure out when is the x value, because it's cosine, a negative root 2 over 2. 3 pi over 4. Right here is where it's a negative root 2 over 2. The x value. Okay? So this is going to be 3 pi over 4, and then it's going to be multiplied with 1/2. Right? So it'll be 3 pi over 8. So 3 pi over 8 is now that y value here. So we'll say, whoops, y minus 3 pi over 8, x minus negative root 2 over 2. And now all I need is just the slope. All right, so let's derive this so I can start to get my slope. So f prime of x, constant multiple rule, 1/2. And what's the derivative of arc cosine of x? The square root of 1 minus x squared. There you go. And now, what am I going to put in here? Negative root 2 over 2. And that's going to go where x is at, so I can see what the derivative is going to be. So, right here. So negative root 2 over 2 squared is 1/2, or 2 over 4, right? So positive 2 over 4, which is 1/2, I have negative 1, 2, 1 minus 1/2. So 1 minus 1/2 is a half. And the square root of 1/2 is the same as the square root of 1 over the square root of 2. You see how I'm doing that?
Yeah.
Let me make sure that we're doing this correctly. 1/2, yep. So this becomes negative 1 over 2 over root 2.
So it becomes negative root 2, so 2 squared 1/2.
Because this is 1/2, right?
Yeah.
And what's the square root of 1? 1.
Well, yeah, I understand why, but why would you do that? Why would you just
Oh,
take the square root 1/2?
It's going to be the same way either way. When we flip it, negative 1 divided by 2 over root 2 is going to be the same as keep, change, flip, right? So my slope becomes, this is just a coincidence, it becomes the same as that. So then I'm going to put negative root 2 over 2.
Wait, I thought to find
So, in all, this would be your answer in point slope formula. Again, you don't have to put in y-intercept if you don't want to.
Wait, you said like why is the x value 3 pi over 4 and not 5 pi over 4 or something else?
Because arc cosine's range is from 0 to pi. Remember we talked about that in last class?
Okay,
And real
we have
quick,
composite.
here's cosine, right? Just real quick. Here's sine, or arc, or sine, and then you have tangent. So everywhere on these graphs where it would pass the horizontal line test is what you're going to show the range of arc sine, arc cosine, and arc tangent. So arc cosine is from 0 to pi, which is right here. This is cosines. Again, where it passes the horizontal line test is where this will pass the vertical line test. So sines and tangents is going to be from negative pi over 2 to pi over 2. And again, that was from day one's notes as far as it was like the very first slide of inverse trig. And it looks like right there, all of this stuff right here. Questions? Alright, so I'm going to stop the video. We're going to go for bonus points.